Okay, for the honor supplement, we have two impedances, Z1 and Z2, and they give us Z1 and Z2, so we have to solve for ZT. Now, I have an equation for 1 over ZT, so I want to figure out what ZT would be. So the first thing I'm going to do is I'm going to combine these fractions together. And the hint. First, rearrange the total resistance equation above so that ZT is in our numerator on top of the fraction. So, if I want my right-hand side to be all in one fraction, I know that my least common denominator is going to be Z1 times Z2. So that means this fraction is missing a times Z2, and whatever I do to the bottom, I do to the top. And this fraction is missing a times Z1. Whatever I do to the bottom, I do to the top. So then I have 1 over ZT is equal to Z2 over Z1 Z2 plus Z1 over Z1 Z2. So now my fractions can combine. Sorry. And I have Z1 plus Z2 all over Z1, Z2. So now if I want ZT, I can take the reciprocal of both sides, and I get ZT over 1, which I don't really need, is equal to Z1, Z2 over Z1 plus Z2. Now if you got this far and then just plugged in what Z1 and Z2 is, then I gave you full credit. So this would equal 200 minus 40j times 60 plus 130j all over 200 minus 40j plus 60 plus 130j. On my numerator I would multiply, so I would distribute, and my denominator I would just combine like terms. And after doing that, I would get my answer of ZT is equal to 87.2 plus 60.6J, and this would be in ohms. If you got to this step here with the setup, I gave you full credit. But this would be the final answer.